Hey everyone, today's video is going to be over solving inequalities with variables on both sides. So your objective, I will be able to solve an inequality with variables on both sides. So keep in mind, whenever we solve inequalities, it is very similar to solving an equation. So all of our steps are going to be the same, but the only difference is going to be possibly needing to flip that inequality symbol. So remember, the first thing that we want to do is we want to cancel one of the variables from either the left or right hand side. Then we'll have a normal two-step equation, so we'll cancel the constant, then we will cancel the coefficient. Now this is the step where it may be a little different than an equation. If we have to multiply or divide by a negative number, then we are going to have to flip that inequality symbol. And then we would check and graph. So let's do a couple of examples together. Example 1, we have 2x plus 4 is less than 5x minus 2. So I'm going to separate the left and right side of this inequality. So I want to cancel one of the terms that contains a variable. I always choose the one that has a smaller coefficient, so I'm going to use an inverse operation. So I'm going to subtract 2x on each side. So this creates a zero pair, and I'm left with a positive 4. I carry down the symbol. 5x minus 2x is 3x, and I'm carrying down the minus 2. So now I have a normal two-step inequality. So again, I'm going to separate the left and right sides. I'm going to cancel the constant, so I'm going to add 2 to each side. 4 plus 2 is 6. Carry down the symbol, and we have 3x, and that was a zero pair. So this is the step where you really want to be careful. So we know that we're going to have to divide by 3 on each side. This is a positive 3, so since it's positive, we can leave our symbol exactly the way that it is. So 6 divided by 3 is 2. And on the other side, we are left with 1x. Now, here's another thing that you want to make sure you do. When you get to your final solution, you need to have the variable on the left. So we want to rewrite this. So I want x on the left, and I want 2 on the right. Now, keep in mind that if we were to look at this x is greater than 2. So I want to make sure that this says x is greater than 2 whenever I rewrite it. So if x is greater than 2, then I can pick any value that is greater than 2. I can plug it into the original inequality, and it should be true. So I'm just going to use 3. So if x was 3, that means we would have 2 times 3 plus 4. And when I solve that, it should be less than 5 times 3 minus 2. So this would be 6 plus 4, and this would be 15 minus 2. 6 plus 4 is 10. 15 minus 2 is 13. Yes, 10 is less than 13, so we know that our solution is correct. And now I'm going to graph it. So my solution, x is greater than 2. I want to put 2 on a number line, fill in some numbers around it. I'm going to have an open circle, and it's going to be shaded to the right because our solution set is greater than 2. All right, example 2, we have 5x minus 9 is less than negative 4x minus 12. So again, I am going to separate the left and right sides. Now I want to cancel one of the terms that has the variable in it. So again, I'm going to choose this term because it has the smaller coefficient. So I'm going to add 4x to each side. I'm going to carry down the symbol. 5x plus 4x is 9x. And I'm going to bring down the minus 9. We have a zero pair, and then we have a negative 12. Don't forget to bring down that negative symbol. So now we have just a normal two-step inequality. I'm going to separate the left and right sides and bring down the symbol. I want to cancel the constant, so I'm going to add 9 to each side. That's a 0 pair. We're left with 9x. Then we have a negative 12 plus 9, and that would be a negative 3. Now that we're at this step, we know that to cancel the coefficient, we need to divide by 9. This is a positive 9. So since we are dividing by a positive 9, our symbol stays the same. So we have x on the left. Now we have negative 3 divided by 9. So if we were to treat this as a fraction, if we were to reduce it, we would have negative 1/3. Now we're not going to convert that to a decimal because, as you know, 1/3 is repeating, and we cannot literally work with a repeating decimal because we would never stop writing it down. So we're going to leave this as negative 1/3. And x is on the left, so I don't need to worry about rewriting anything. So now I want to check. If x is less than a negative 1/3, then I want to choose a value that's less than negative 1/3. So I'm going to choose a number that's simple to work with, and I'm going to pick a negative 1. So 5 times negative 1 minus 9 should be less than negative 4 times negative 1 minus 12. Alright, so 5 times negative 1 is a negative 5. So negative 5 minus 9 should be less than. Here we have a negative 4 times a negative 1. That's a positive 4. And then we carry down the minus 12. Negative 5 minus 9 would be negative 14. And 4 minus 12 would be negative 8. And negative 14 is less than negative 8, so we know our solution set is accurate. Now I'm going to graph our solution. So from 0 to 1, oh, sorry, that's negative. Hang on, let me start over. Okay, so 0 to negative 1. If we split that into thirds, and I messed up again, I'm so sorry. There we go. Now we have thirds. This would be negative 1/3. We have a less than symbol, so we are going to have an open circle, and we are going to shade to the left because all the values less than negative 1/3 are part of the solution set. So in both of our examples, when we got to our last step, we multiplied or divided by a positive number, but just keep in mind if it is negative, then you are going to have to flip that inequality symbol. Okay, now it is time for you to try. Go ahead and solve these two problems in your spiral. Make sure you have everything from the notes recorded, and we will see you next class day.